Using intercepts. Intercepts tell you where the graph crosses the x-axis and the y-axis. If the line crosses the x-axis, you have an x-intercept. If the line crosses the y-axis, you have a y-intercept. Let's take a look at the coordinate plane below. We're going to identify the ordered pairs that are on the intercept. So let's take a look at this point right here. What is that point? That point is, it's an x-intercept, and it is 2, 0. Now let's take a look at where it crosses up here. That's a y-intercept, and it is 0, 4. What do you observe about these ordered pairs? Hopefully you've noticed that when you have an x-intercept, that y value is 0, and when you have a y-intercept, the x value is 0. So keeping this in mind, when you're given an equation, you can find the intercepts by replacing the x or y values with 0 and then solve. So let's take a look at 3x minus 2y equals 12. So I'm going to try and solve for x. So I want to find out what x is, which means I'm looking for an x-intercept. So I know that to have an x-intercept, my y value must be 0. So I'm going to make that y value be 0, and I get 3x minus 0 equals 12. 3x equals 12, or x equals 4. So I have 4, 0 is my x-intercept. Now I'm going to go ahead and look for my y-intercept, which means my x will be 0. And we're just going to substitute it in. 3 times 0 minus 2y is 12. 0 minus 2y equals 12. Negative 2y is 12. Y is negative 6. So I have an x-intercept of 4, 0 and a y-intercept of 0, negative 6. Let's take a look at these problems. Negative 3x plus 5y is 30. So I'm going to look for my x-intercept, which means my y is 0. And then over here I'll do my y-intercept, which means my x is 0. The reason I just write these up top is it just keeps me focused as to what I'm going to be making 0 and what I'm actually looking for. So we have negative 3x plus 5 times 0 is 30. Negative 3x is 30. X is negative 10. And then over here, we have negative 3 times 0 plus 5y is 30. 5y is 30. Y is 6. And those are our two ordered pairs, our two intercepts up there. Go ahead and pause the video and try 4x plus 2y is 16 on your own. Let's see what you have. So we have your x-intercept. Four x, 2 times 0 is 16. X equals 4. Over here we have 4 times 0 plus 2y is 16. 2y is 16. Y is 8. Oops. And there's our ordered pairs here. Now there's a shortcut method, and it's called cover-up method. It only works if your equations are in standard form, which means it has to be ax plus by equals c. And basically what it's doing here is you're literally taking your finger and covering up that part that's going to be 0. So if you are looking for the x-intercept, which means your y is 0, you're literally scratching that out. And you can just see negative 3x equals 30. And now you can see that your x is negative 10. And then on this side, when you're looking for the y, you're going to scratch that out, cover it up, 5y equals 30, and you get y equals 6. So go ahead and just take a look at these next two problems, that 4x plus 2y, and just pretend that if you covered up that one term, either the 4x or the 2y, you would get the same answer. It's just a shortcut, but you need to understand why it works. And it only works if you're in standard form. So down here at the bottom, it says, can we use cover-up method here? We have y equals 2x plus 4. It doesn't work. You can, you have to put it in ax plus by equals c format. So it would be easy to actually go ahead and just, manipulate these and subtract the 2x from both sides, and you have negative 2x plus y equals 4. And if you just go ahead, I'm going to write that over here as well, negative 2x plus y equals 4. If you just scratch out that, you have y equals 4. So that gives you 0, 4. And if you scratched out the y and made that 0, you would have negative 2, 0. I'm going to divide both sides by 2. So you can take your equations and turn it into standard form, or you can simply just substitute in the 0 for the x and solve for y, substitute the y, 0 for y, and solve there. But either way would work. We're going to look at these intercepts and graph a line. I'm going to use cover-up method just to make it a little bit easier. So if I just wanted to basically cover up this negative 4y, I would end up with 2x equals 8. X is 4, which means my first point is at 4, 0. If I did the other one, it would be 4y equals 8. Y is negative 2, which is 0, negative 2, over 4, up 0, negative 2. And then with a ruler, you're just going to connect those. And extend your line all the way, completely diagonal. Please don't stop at the 2 and the 4, but just bring it all the way out. This last one here, we have 2/3 y equals 4 minus 1/2 x. My little hint here, would it be easier to write this in standard form? And if we did, we would have to add 1/2 x to both sides. So we're getting 1/2 x plus 2/3 y equals 4. And now you're saying, okay, how am I going to solve for this? Well, you can, death to fractions, multiply by a common denominator, or you can just say 1/2 x equals 4, and then go ahead and remember, multiply by the reciprocal. You have x equals 8. So this is 8, 0. And on the other side, it is 2/3 y equals 4, multiplied by 3/2, and y equals 6. So you have 0, 6, which is way up here, 8, 0, way over here, and connect those dots.